Guys, this is Integrated Science Unit 2, Applications of Forces, Part 1. We're talking about pressure, and this is the fourth part of this note series. So today we're going to talk about if you have liquid and you compress on one end with a force, what happens on the other end. So the thing we have to know that if you have a pressure change in one part of a fluid, remember a fluid is anything that flows, so a gas or a liquid, and it's in a closed container, then that pressure change is going to be transmitted without loss to every portion of the fluid on the walls of the container. Now there are different pressures throughout the fluid, but the rate of change is going to be the same. So let's say we have this apparatus. So this is connected, these are two pistons. So a piston here, a piston here. We'll call this situation 1 on the left, situation 2 on the right. And we are applying a force on piston 1. And that's going to press down here into this liquid that's all compressed at a high rate. So when we apply this force, it's going to create pressure down here. So it's going to build up pressure, and that'll result, because it's transmitted through, to a force coming out on the right, which is force 2. Now notice there are differences. We have different size pistons. Now if they were the same size, we would end up getting the same force, but when they're not the same size, we have to keep in mind that there is a pressure 1 under force 1, and we'll call it pressure 2 under force 2. The piston under force 1 is labeled area 1. So notice everything on this side all has a 1. So it's all associated together. And then if we look on the right, we also have an area of the piston. So that's how wide that apparatus is on the side that it's exiting. We can also call the one side the input side and the two side the output side, because the force is coming out of the apparatus on the second side. So we know if we look on one side, the pressure 1 is equal to the force divided by the area, and that's just the definition of pressure. Pressure 2 is force 2 divided by area 2. Now what we know is initially these pressures are the same because they're at the same level. So in the last notes we talked about how pressure changes based on how deep within a fluid. So if these are starting at the same, then their rate of change is also going to be related. So if P1 equals P2, then we can say that force 1 divided by area 1, which is P1. So P1 is force 1 divided by area 1. So another way to say pressure 1 is force 1 divided by area 1. P2, another way to say that is force 2 divided by area 2. So I can take this P2 and replace it by force 2 divided by area 2. So that gives me this formula, which I will move my face for. So this is Pascal's principle, that if you have this pressurized fluid between two pistons, then the input force divided by the area of the input piston, or everything over here on the left, is equal to the output force divided by the output area. So you can solve for pieces of this by two fractions set equal to each other, so you cross multiply to make it a very basic algebraic equation. Let's work out a practice problem. So let's assume that a force of 50,000 newtons is required to get this car moving. So we need this outwards force to be 50,000 newtons. If the area under the piston of the car is 25 meters squared, and the area under the first piston over here is 0.03 meters squared, what force do you need to apply to the first piston? So what force here to move the car? So we don't know force 1, but we're going to divide it by area 1. So area 1 is not the area under car, the other one. So that's 0.03. And you set that equal to, for force 2, that's the output force. So whatever force is coming up, so 50,000 newtons, and you divide that by area 2. So the area under the car is 25. Cross multiply, and that gives you 0.03 times 50,000, because you would go across here and you multiply, equals force 1 times 25. You're trying to solve for the force. Since the force over here is being multiplied by 25, the opposite function of multiplication is division. There's nothing else over here, so you can go ahead and start dividing by that. So divided by 25 on the right. So you have to divide by 25 on the left. and you find that you actually only need 60 newtons of force to get this whole thing moving. So what's really cool is you only put in 60 newtons of force down, but you're going to get 50,000 newtons of force up, which is crazy. You're getting so much more because that pressure is going and it's brought along to all the points under this big piston here. So even though you put a little pressure on this, it transmits to all the pressure over here. And this is how things like the brakes in your car work. I mean, you shouldn't be able to just press something and your car stops because cars are really hard to stop just by pushing with your foot. Like if a car hit you and you pushed it with your foot, you wouldn't stop it, right? But your brake system is able to use hydraulics to take a small pressure and then disperse it out into all sorts of different parts in the braking system to actually stop the car, to create a larger force. That's why if you ever have a leak in your brakes, then they will not work and your car will not, I mean, depending on the leak, but that's very, very, very dangerous. You don't ever want that because then if you had a leak here, the pressure wouldn't transfer over to continue to make that giant push. Whenever you do a small amount of work but get a large amount of work done, that's called having the mechanical advantage. So whenever you're putting in a small force to get a large force out, it's the mechanical advantage. And that's something that's really important to, once you know the properties of physics, you can apply it to make your life a lot easier. All right, so that is it for these notes, and best of luck with this section. See you in the next video.